Hi everybody, let's talk about the movement of tectonic plates. So we have four models over here, and the first one is convection currents. Essentially, here's a diagram of the Earth, and here is the core. The core is the hottest part of the Earth, and it heats up. It acts as the heating source for the mantle. The mantle has your material, a lot of liquid, fluid, magma, and it's getting heated up by the core. So the material near the core will start to rise because the hotter the material are, the further apart they are, so they're less dense and they want to rise relative to other materials in the mantle. So as they rise, they begin to cool down because they're further away from the heat source, but and they want to sink, but they're getting pushed up by the rising magma below them, so they don't sink yet until they reach the surface. Some may escape through diverging plate boundaries such as this, but most will spread out because of the lithosphere blocking it, and then it will sink because it's colder relative to the other areas. You can see here with diverging ones and here with converging ones. It's the same mechanism, but they form different plate boundaries. Here you form diverging plate boundaries here and converging plate boundaries here. Let's move on to ridge push. Ridge push is when you get a buildup of pillow lava, buildup of new crust in diverging plate boundaries. It adds mass to the area, and when you have more mass, you're more under the effect of gravity, so your crust begins to slump out, and it helps accelerate this pushing movement. And it is initially driven by convection currents, but gravity plays an effect on this. Same as this with slab pull, gravity also plays an effect. As it subducts, as the any plate subducts, it will offset the center of gravity, and it makes this part as a column heavier than this part as a column, which makes it under the effect of gravity more, and therefore the entire plate gets pulled alongside with it, which accelerates the movement, and it pulls any parts like this area onwards. And now hotspots are kind of completely different. They don't happen at plate boundaries at all. In fact, hotspots, they happen in the middle of nowhere. You can see in Hawaii, it's in the middle of the Pacific Ocean with no plate boundaries, but they still happen. So you have any convection currents, any magma wanting to rise up, and there are no plate boundaries here. There are no gaps or fissures caused by plate boundaries, but they still rise because there are still cracks or points of weaknesses, areas of weaknesses in the Earth's crust and lithosphere. So they're able to rise up and eventually erupt, forming volcanoes called hotspots, such as the ones you see in Hawaii. So that's about it for the movement of tectonic plates. I hope you guys enjoyed and understand how tectonic plates move.